Hello viewers, welcome to add-on. In this question we are asked what will be the representation of the hexadecimal number 6DE in decimal. Okay, so the number which is given to us is 6DE, and here H is specified. We specified it is a hexadecimal number, but we can also specify it as 6DE with a radix of 16. This also specifies that the given number is a hexadecimal number. Okay, but other than that we can clearly see that the numbers D and E are mentioned, which are only possible in hexadecimal number, because for binary number we are only getting 0 and 1, and for octal number we will be getting up to 8. So if D or E are mentioned, we can also say that it is a hexadecimal number. Okay, so for the representation of a hexadecimal number, and in the decimal number system, that means from the hexadecimal number 60 with a base of 16, we will be getting some number with a base of 10. We specify that the number is in decimal number system. So for this conversion process, we need to understand the concept of positional weights. What do we mean by positional weights? Consider this is the number 60e. So this has a radix of 16. So we need to remember that for positional weights, we first need to look at the number which is present on the absolute right hand side. For example, in this case, the number which is present on the absolute right hand side is E. Okay, so from that number which is present in the absolute right hand side, we will start our positional weights, and the positional weight will start as the radix which is given to us. We will write the positional weight as the radix to the power 0 for the number which is present on the absolute right hand side. So in this scenario for E, it is the number which is present on the absolute right hand side, and here our radix is 16. So as I have said, for the number on the absolute right hand side, we will start the positional weight as 16 to the power 0. Okay, so for this E, we will get a positional weight of 16 to the power 0, and then as we move to the left hand side of the number, as we move to the left hand side, our positional weight will increase in the power of 1. For example, for D we will getting 16 to the power 1, for 6 we will getting 16 to the power 2, and if the hexadecimal number is more in length to the left hand side, we will get 16 to the power 3, 4, likewise. Okay, so now for the conversion process, what we will do, we will multiply each of these positional weights, this 16 to the power 2, 16 to the power 1, 16 to the power 0, with the particular number they are associated with it. Like 16 to the power 2 into 6, 16 to the power 1 into D, 16 to the power 0 into E. And after that, we will add the product of the multiplication together to get the equivalent decimal number. Okay, so what do we need to do? We need to multiply the positional weight with the respective number they are associated with it. So 16 to the power 2 into 6, and I have said that we need to multiply the positional weight with the number they are associated with it, and then we need to add those products together. So we will write 16 to the power 2 into 6 plus 16 to the power 1 into D plus 16 to the power 0 into E. Now if we look at the options here, there is no finalized calculation, so we will not do the maths here. We will just convert this D and E into their decimal equivalent. So as we know, for a hexadecimal number system, 0 to 9 is represented like 0 to 9, similar to decimal. For 10 we will get A, for 11 we will get B, for 12 we will get C, for 13 we will get D, for 14 we will get E, and for 15 we will get F. So here we will replace D by 13 and replace E by 14. So 16 to the power 2 into 6 plus 16 to the power 1 into 13 plus 16 to the power 0 into 14. Okay, so this will be our final answer, and in this case it will be our option number A. Okay, thank you.